Hello to everybody from Romania with love. Not with love, with seriousness. Hold on. Hello to everybody from Romania, from your favorite artist here. I finally solved the problem of 7433. I will probably, no, I have it. Yeah, I will probably have to mount the phone a little bit up to actually show you everything. And I have, here are the probes of the oscilloscope. You can see it there. And my Hercules oscilloscope. One that can do everything but nothing in the same time. And so these two chips that I have here, this one and this one, are the same chip, 7433, which is an OR gate. Here is the circuit diagram, how it looks, and I will leave it somewhere here to easy reference to it, because I have 1, 2, and 3 is the output, and 6 output. So I have 2 outputs on this side, and on 11 and 8, I have the other outputs. So I kind of, I'm doing it, you know, so it's not having absolutely any kind of input there. I'm only probing right now its output. That's it. This is only what I'm doing. And of course, I'm powering the chip itself, positive and negative here, as it says here. VCC on pin 14 and ground on 7. All right. What I have there on the oscilloscope is noise. I don't know. It's pretty square. It's pretty square. So that's on this pin, on this output. The same goes for all the outputs. You have to believe me, but not really the same. Sometimes it's just staying up to the high volts. Right now is on that particular output, and if I'm taking it out, is going to the negative. Now when I'm putting it to this output, also jumps high with some spikes, noise, whatever it is. But the bad thing is that it's jumping automatically up. And if I'm putting it, so it was here, so now if I'm putting it here, also is staying up to the 5 volts. So the outputs of this chip, if the inputs are not connected to ground, both of them should be connected to ground, the output will stay high every time, which was a very, very bad thing for me to figure it out. Actually, I spent like probably half a day last night, a couple of very good hours, and today another couple of good hours. I spent all this time to figure out 12 hours, exactly, pretty much like a half a day. Like 12 hours, I stayed non-stop on this small circuit that it didn't give me the results that I wanted. And I'll try to show you the, 1 second. So let me put my sticks for the phone, to put it here, when they are flat, equal. Now, perfectly horizontal. So let's see if, kind of, you can see everything, if I'm pushing everything up, kind of. Okay, so I'm interested here to show you. Also there. So I have these resistors already installed. Everything is working, is functioning perfectly right now. Absolutely fine. But it didn't work perfectly at all. First of all, I didn't get this result all the time. I discovered this chip is having one gate burned or non-functional, one of the 4 that is having, so only 3 of them were functional. And I was getting all sorts of weird and random output there, and I couldn't understand how the hell. And I put capacitors here, there, a lot of resistors. As you can see, I have a good batch of resistors. Let me actually show you how I originally mounted. I put it for a very long time. Actually, it was like this. So right now I have 1 kilo on all the inputs all at once. So I have 1 kilo on all the inputs of this OR gate. So for all of them, for these 2 inputs, these 2 inputs, 2 inputs, 2 inputs. So all 8 of them are dragged down, are pushed down to the ground through this 1 kilo. And originally I didn't put these diodes when I was using this chip, and probably that's why. Probably I put a 5 volts on one of its inputs, and its output got damaged. It's not burned. It's still functional, but I have to really, it's not sensitive anymore. I have to actually bring it down to 0 volts with a wire, one of its inputs, that the output should switch. If I'm using resistors, it doesn't work. For only one OR gate that is having. The rest are the same as this one. It's pretty good. But I did a mistake testing, and and I was believing these chips are bad. I was strongly believing that I got a bad batch of chips, but also I was thinking I should try better and I should try more until I will figure it out. And I did, thank God. And it is very, very, very weird. Very weird. Usually 10 kilo and 1 kilo is giving me the results that I want, usually. In most of the cases, like, I don't know, 98% of the cases, I get very good results with 1 kilo and 10 kilo if I'm switching between them. Very, very rarely I'm using 100 kilo and 1 mega. So now, let me show you the experiments that I did here also. Let's see. So I will use a jumper like this, wire jumper. So right now, I'm connecting the one of the outputs to the oscilloscope, and here is one of the inputs connected to negative, and the oscilloscope is still high if I'm not connecting it. So if I'm taking it out, is oscillating, you know, and if I'm putting it in like that, it's not oscillating but only staying high. Very interesting, no? And now, if I'm putting the other input, connecting it, and also to the ground here, ta-da! The output right now is reading as 0 volts to the ground. Absolutely brilliant. But this is not good because I've connected directly the wires to the input. So I don't really, it's not really practical unless I only have a totally digital input somehow, and not that using resistors like I'm intending. So right now I'm using, let me take out this. So right now let's put some resistors there. For the moment I will put 1 kilo, as you can read on it, on its color band, on one input, and this is the other input, and I still have 0 volts, which is absolutely gorgeous, absolutely good. But I believe this was the troublemaker. This output is staying high, right? So I've connected the two inputs of this OR gate, and the output is there, but the output is not going to the negative. These two, and this one here on the top are perfectly fine with 1 kilo, but only this guy here is staying up, and I couldn't understand what is going on. Why? Because all of those three, until I realized that all three they are working okay, and only this guy was staying high. Then I understood that this might be broken, and how to actually repair it and make it work, because I couldn't believe it is absolutely broken totally, because I did the wire test and it worked. So only one input here if I'm connecting it with a wire, but the other one I leave it with 1 kilo to the ground, of course. Let's see if I'm lucky, and I am lucky. So one input, you see, this is how it's staying positive, and when I'm connecting this wire, it's going negative. Hoppa. So now I understood that this particular OR gate that I have there inside is still functioning, but not at the right parameters as the other ones. It's not that sensitive, is broken, you know, but still functioning. If you really want it to function, to make it work, you can, but you have to bring it down to 0 volts, literally. And it's yeah. So I took out another chip, and as these three of them were working with 1 kilo, I tested the same. I put it here, that one, and all four of them were behaving nominally with 1 kilo on each of the inputs. Okay, that's one side of the story. But this guy here that is doing something very interesting right now, but before it was very weird. It was behaving very weirdly. Also, probably I was having a lot of stuff here, other stuff that I had. You know, if I was resetting from the negative, I was taking it out, you know, and putting it in. It was changing a little bit the behavior because some capacitance somewhere was holding some kind of memory and was behaving in a certain way. A little bit, small details, but you know, shit like this is happening usually in reality. And and with 1 kilo, it didn't. It did all. Let me put. It didn't work as I planned. As I make it in. Let me put it here for a moment. As I use it in Proteus. You've seen already how it is working with 1 kilo, but I will show you again right now very quickly. I'll connect very quickly the 1 kilo, and it should work theoretically, but it didn't. It doesn't work as it is alone when I'm testing it alone like that. And I was scratching my. I scratched my head a long time. Also, these LEDs are getting very dim as well, and I noticed a lot of. After I noticed a lot of little details like this, I start to wonder. Well, let's see if I'm putting a 10 kilo. I tested it here, and let's see if it's working with 10 kilo instead of 1 kilo. And I put 10 kilo. Let's see, where are you? Also, I played a lot with the capacitors because in the simulation they give me some smoothness, some good results. So here's 10 kilo. But here in reality, the capacitors didn't really help me. I didn't. Yeah, they didn't do anything important, you know, or decisive good. I mean. So yeah, right now when I'm putting this 10 kilo, I'm having a little bit of a different behavior here. It was this two and this two lighting up, but I had another problem. I misplaced this resistor that is here, the last one, the last gate. I put it here on 3, and this guy here, which is the third one, on the 4th, and it was inverse. And then I realized I have those resistors not in actual order, that I wired these wires here on this, and now it is correct. And yeah, so I've noticed that is starting to pulse with 10 kilo is starting to do something erroneously, of course, but it's starting to do something. So I said, oh, this is interesting, and I said I will go crazy and I will put 100 kilo, which is this guys here, and let's switch them off. So I will take the 10 kilo out, and I'll get the 100 kilo here, and I'll put them the same on the negative. And because I was having that LED messed up, I was thinking I was having an erroneous behavior from the chip itself. I couldn't really understood what is going on. Let's see how it's doing right now. No, it's still erroneous with 100 kilo. It's still erroneous right now. Okay. As it was with 10 kilo. So 100 kilo or 10 kilo is still erroneous. I don't know what I was thinking at the moment, what I observed, but I said, let me put 1 fucking mega, 1 mega ohms. This guys, and let's see if the behavior will improve. And I'm doing it like so. I believe I noticed when I put 1 or 2 here, I noticed some changes there, and then I get courage to put them all. And nu s-o mai ars, că nu s-a ars nimica. Eu am uitat-o cu apa întrânsă. Și acum am făcut-o. So now when I put the 1 mega resistors, the behavior improved, totally improved. If I'm not putting these diodes, the behavior is erroneous without these diodes, unfortunately. It's probably because of those outputs that I have there, because of those LEDs, those resistors and those LEDs. And I was keeping in mind this deficiency, if you want, because these are very small resistance, 470 ohms resistors to drive those LEDs. And I was thinking that the signal that I get from there is very weak. It's extremely weak signal. And probably I was letting too much current surge into the ground before it was actually reaching the inputs of the OR gate that I have here, of the chip. So that was my logic. That was the way I thought about this problem and how to resolve it. I see the problem as the current here from these lines was going into the negative rail before it was reaching there. So that was the logic, to add a little bit more resistance here, also keeping in the same time these inputs to the ground. When no signal is coming, they are grounded through all this 1 mega resistor. But when the signal is coming, it is strong enough, even as weak as it is from there, coming here, is very weak signal. 2 volts, if the resistance is very low, it will surge very quickly into the ground. So this way I'm permitting, because not too big current is surging through all these 1 mega resistors from the signal itself. So it is permitting to actually activate the inputs normally or correctly. So this was very hard, very hard actually it was to figure it out. But I kind of figured it out in a record time because I really wanted I really wanted to make it work, you know. And also the stepping is the same as there. If right now you can see is moving from top down and then restarting from top again. But if I'm switching the other sense, it will start from here, there, and starting again. You see, from here to here to here. So it's this direction. And if I'm switching it, it's this direction. Absolutely brilliant. So pretty much what I did here, like I said before, I've converted that signal that is there into this signal that is absolutely different from that one, as I demonstrated already, and I showed everything. I hope you like it. This is the demonstration. This is the steps. These are the steps that I took to figure out all this thing. In the process, I burned 1 single gate. For some reason, I don't know why it was. Probably it came with that gate already burned, but most probably I did it. I don't know how I managed to do it, but I did it. And it's a shame, but it's a good. It's an it's an acceptable loss, very acceptable loss. I still have 3 of them good enough. So another project maybe I will use only a part of it, the good part, and I will have to mark it to specifically say which one is the burned one. And yeah, it's working absolutely gorgeous. And this circuit is a bit different from the original circuit that I made in Proteus, and I will update that circuit in Proteus as well to fit exactly what I have here in reality. And this signal from here will go to the motor somewhere there. It will go, and from this chip it will go further to this bastard motor that is running extremely slowly and not much torque in it. I hate it. I'm not hating it. I'm mad. I'm upset because they cost a lot of money and they are not doing really any good job at all. And I'm very upset on them. I hope this will solve the problem. This signal that I made right now made it work. It will work and improve the motor behavior. All right, this is the circuit actually that I built there on the breadboard. So this was the original file, this one, and this is version 2 right now. I've included these diodes here. I have 1N4148. I've included these resistors, 4 resistors to the ground, 1 mega per each resistor. But here in Proteus Simulator, it doesn't really work with 1 mega, but it does work with 1 kilo, as normally should. But Proteus doesn't know about that very weak signal that I have there. So I had to calibrate what I had in reality to the impulse and the inputs that I was having there. And but here is I put this label here as 1 mega for each. Very good to remind me of what I did in reality there. And the rest, I don't think I used the capacitor, but I will. No, I didn't use the capacitors. But I leave it here because I don't know. I believe it's smoothing. Let me actually test a little bit to see if it's smoothing. And yeah. Here on the oscilloscope, I have that little dick. You see, only on the yellow. It should be smooth in reality, but in reality it's not really that important or decisive that is actually damaging the normal behavior of the circuit. So it's good enough, but I will keep it here as a reminder that it's good for smoothing pretty much. These are the output lines that I am having here, and the oscilloscope is on the output lines. Although the capacitor, it appears that is smoothing the LED and its resistor. By the way, 10 kilo, exactly how I use it in reality as well. Although this capacitor is appearing that is smoothing this area, but is actually smoothing the logic line that the output, this output line is smoothing it. And I've also added this correct naming of this pulse. Full step drive is called, all right, and also here it's called wave drive. I've actually reopened the Wikipedia, let's see, the Wikipedia page here, and wave drive was the first, full step drive is the second, and it's absolutely brilliant. Pretty much this is it. This is the entire. This is the difference from reality, and now I have it here in Proteus. Pretty much this is it. Yeah, I'm very happy with the results. Very, very happy with the results. I hope you like it. Thank you very much for watching, and also leave a like, and see you later.